Hey everybody, this is 7.3 Power Functions and Function Operations, Part 1. So now with 7.3 we're going to apply what we learned with exponent rules and radical rules to some situations, and our goal with this section is to add, subtract, multiply, and divide different functions. Just a quick little remembrance of some past math facts that you guys should know with our warm-up today. So why don't you pause the video and go ahead and try 1, 2, and 3 here for the warm-up. Alright, check your answers. For the first one you should have 4x cubed plus 4x. We just distributed the 4x. And for the second one, watch out, because remember, if there is a plus or minus sign in the parentheses, you can't distribute the exponent. Instead, we have to write it out twice and FOIL it. So the correct answer is x squared minus 4x plus 4. And then last but not least, here I'm hoping you'll remember to distribute the negative there. And so our final answer ends up being 4x minus 6. Alright, review from Geometry 2. A function. A function is a relation in which every input has exactly one output. Every input has exactly one output. Another way we could say that is every domain has exactly one range. And just a quick reminder, domain or the input is x and the range or the output is y. So function, every input has only one output, and then with our adding and subtracting we're going to be talking about how to find the domain of some of these. And just to review, remember the domain or the input, they're just the possible x values we could use in the function. And function notation uses a f of x, it's called, instead of y. Alright, so first we're going to add or subtract these functions. So function can come in many different forms. Here's two examples. When it says find f of x plus g of x, we're actually just going to literally add these. And this is where your exponent knowledge comes in from section 7.1 and 7.2. So we're just going to add it. That's it. These have the same base, or not the same base I guess, but I should say the same variable. Same base, same exponent, I don't know. 2 plus negative 6 is negative 4. And then one thing you should think about, this would be the correct answer, but also remember a 1/2 power is the square root of x. We are also supposed to right now find the domain. So we just added or subtracted the function. Here's our answer, either one of these, and now we're going to find the domain. So that just means the possible values we could use. The possible values we could use for x. So we just have to think about this a little bit. If I think about just kind of some math facts here, if I have a square root of x, I can't have any negatives for x because we can't take the square root of a negative. We'll get imaginary numbers. And another math fact, we can't have x on bottom of a fraction because that makes we can't have 0 on the bottom of a fraction because that makes it undefined. So those are kind of the two main things you're looking for, and I'll say more as we go along. In this situation I do have a square root of x, so x can't be negative. X could be 0, so here's what I'll say. I'll say that the domain is x is greater than or equal to 0. Alright, now let's subtract these functions. So same exact thing we just did, only with a subtract sign in the middle. And I have a double subtract here, so it actually kind of turns into plus. So 8x to the 1/2 is my answer, and this one still has, really, it's a square root of x. So my domain again, and we can abbreviate that d. If you say d, you'll know what you mean. X is greater than or equal to 0 for the domain. Alright, pause the video and try part B. If you've unpaused, let's check your work. We should have 5x to the 1/3 for your answer for this one, and we should have just x to the 1/3 for our answer for this one. And I want to talk about the domain a little bit though, because there's something, well, you should just know a 1/3 exponent is the cubed root of x, and remember from what we've been talking about in class, we can have a cubed root of x because if I, like, quick side note, try to do the cubed root of -8, for example, or something, it is possible because -2 multiplied by itself 3 times would give us -8. So if I have a cube root of x, I can have negatives, I can have 0, and I can have positives. I can have anything. So I'm going to say that my domain is all real numbers. And it's fine with me if you just say all reals. So my domain is all reals for both of these ones. In general, you'll see me talk about this a little bit, but if you have a even root, like a square root or a fourth root, can't have negatives. If you have an odd root, like a third root or a fifth root or a seventh root, you can have negatives underneath. Moving right along, now we're going to multiply and divide the functions. So what they're going to do is they're going to give us two different functions. We're going to multiply them using some more of our exponent properties here. So now I have my function f of x, I'll fill it in. My function g of x, I'll fill it in. And now you just have to remember our exponent properties. So if I just have a regular x, really it's x to the first. So I'm going to use that exponent property where I'm going to add the power of 1 plus the power of 1/4. So in my mind I'm thinking, okay, 1 plus 1/4, 1 is the same thing as 4/4. Okay, so that's 5/4 total. So 3x to the 5/4 is my answer when I multiply. Now we got to talk about the domain. So here is where your knowledge of changing from a fractional exponent to a radical is going to come into play. Just a quick remembrance, the bottom number is the root number. The top number is the power, and you could write it like this, or I could write it like this. But either way, you can see we have an even root. Remember what I just said? We can't have a negative underneath an even root. Not possible, we get an imaginary number. So my domain, for example, 2a is x is greater than or equal to 0 again. We can't have any negatives. Now let's do some dividing with those same functions. I'm going to now have 3x divided by x to the 1/4. And remember exponent properties here, I do top subtract bottom, 1 subtract 1/4 for my new power. And 1 subtract 1/4 is 3/4. So I've got 3x to the 3/4. And that, if I convert it, now that would be a fine answer, okay, but if I convert it so that I can more easily think about what my root can be or not, I again have an even root. So I can't have any negatives for x. And then I need to teach you something right now, which I have not yet mentioned. In this situation, at this point at the end of the problem, I don't have a fraction anymore, so you might be thinking that 0 would be okay, but it actually just so happens that if you go throughout your problem, and if at any point within the problem there is an x on bottom of a fraction, that means that we can't have 0 there. So what I got to think about in my mind, what would I put on bottom to make that 0? In this situation it'd just be 0. So I can't have a 0 here at the beginning of the problem, which means we can't have a 0 anywhere throughout the problem. So in this situation, watch closely, I can't have 0 and I can't have negatives, so my domain is actually just x is greater than 0. Not greater than or equal to, but just greater than, because it can't be 0. Please pause the video and try part B. If you have unpaused, let's quickly check your work. You may have used your calculator if needed to add those fractions together, but I end up with 4x to the 5/6 power. And when you convert that to a fraction, or not a fraction I guess, when you convert from a fraction to a radical, you get an even root again, so my domain cannot have negatives. 0 is okay, because I don't have anything on bottom of a fraction. And let's check our answer for the second part of that. When you subtract those exponents, you should end up with 1 over x to the 1/6 power. And this one's a little bit more clear this time. Can't have 0 on bottom of a fraction, so x can't be 0. X can't be negative because we can't have a negative under a even root. So this time the domain is just x is greater than 0. Only positives, no negatives. Hey guys, we're going to now do 7.3 part 2. So at this point we're going to do something called function building, and this is kind of tricky on this page, so please watch closely. Review from GO2. Let's say I had f of x equals x squared plus 8, and then I asked you to find f of 4. You may remember to find f of 4, I would plug in a 4 for x, and then I would evaluate. So in this situation, I end up getting 24, so f of 4 is 24. That's called evaluating something into the function. Now, this does not have to be a number. Instead of having a number there, I could have a variable in the parentheses, and I could have a whole nother function in the parentheses, and that's kind of what we're building up to. For part B, let's say I had f of a then. So again, you can put anything in for x. This time I'm putting a in, and that's not very exciting. That just ends up being a squared plus 8. But still, I plugged an a in into f of a for x. And now, for part C, let's try f of a plus 4. So again, you can plug anything you want to into the function. This one just takes a little bit more effort because I have an a plus 4 with a power, and it has a plus or minus sign with a power, which means I have to write it out twice and then FOIL it. So in my mind, I'm thinking, okay, a squared plus 4a plus 4a plus 16. That's me foiling. I still have the plus 8 from before. So my final answer ends up being a squared plus 8a plus 24. So that's what f of a plus 4 is. Part D, this looks weird. F of g of x. This is notation to show you that we want a function within a function. When you plug one function into another function, it's called a composition of functions. And there's several different notations they could write this in, like I could have g of f of x, I could have f of x, and all these things mean something different. So we're going to do several examples of that. But that's called a composition of functions when I plug a function into another function. And it's best if I just show you. Alright, so here for example 4, I've got two functions. I've got 3 times x to the negative first, that's f, and then my function g is 2x minus 1. For the first part, I want f of g of x. And here's what this means. This means I want to plug g of x in the entire function everywhere, everywhere I see an x. So what that means is g of x is 2x minus 1. Everywhere I see an x in my f, I'm going to plug in the 2x minus 1. So that's the start of it, and then I have to figure out how to simplify it. We remember, hopefully, that when I have a negative exponent, it moves something to the bottom. 3 has its own exponent, it's positive, so that stays on top. But the 2x minus 1 would go on bottom. Whoa, but an exponent of 1 doesn't really matter, so it's kind of like I have this, and this is our answer. Alright. That is my function within a function, but we're going to try to state the domain again this time. Remember how I said our domain is what possible x values you could have. In this situation, we know we can't have 0 on bottom of a fraction, but if I just plug a 0 in for x, that would be okay in this situation, because if I plugged a 0 in for x, that would be 0 subtract 1, which would be negative 1. So I need to figure out what would I plug in on bottom to make it 0? And to figure that out, we always take the bottom and set it equal to 0. And that's to figure out what can I not have. Alright, so let me just go through and solve this quick. I end up with x is 1/2. And let's just really quickly check. If I plug in a 1/2, does it end up being 0? Let's see here. Yeah, 2 times 1/2 is 1. Okay, so x cannot be a half. There's a few different ways you can write that then, and that's all. Everything else would work, because I could put negatives there, I could put positives there, and so on. So my domain this time is all reals except 1/2. And if you want to be kind of lazy about it, sometimes people say x cannot be 1/2. And if you write that, people would assume you mean all the rest of the reals would be possible. Alright, so let's try a few more. I gotta tell you, usually it takes people several of these to get the hang of it, so if you're still feeling confused, just keep listening. Next, I want to do g of f of x. So this time, I am going to take what f is, and my f function is this, and that means that anywhere I see a x in my g, I'm going to plug this 3x to the -1 in. So g looks like 2 times x minus 1. What I'm saying is we're going to erase the x of g, and we're going to put in this other function. And now I'm going to simplify it. 2 times 3 is 6. And I have a negative exponent, so that x to the first moves to the bottom of the fraction. So that is my g of f of x right now. And if you look at this one, I don't have any square roots, so I don't have to worry about negatives. I do have something on bottom of a fraction, so I'm trying to think for my domain what possible x values would work. And in this situation, it's just a regular x on bottom, so I can't have 0 equal to x. That wouldn't work. So my domain is all reals except 0. Alright, sometimes you have to do a function within itself. So my last little part here is f of x. So remember, f of x was 3x to the -1, again. And this is going to seem kind of crazy, but f of x was this. What this means is I'm going to erase my x, and I'm going to plug this function into itself. Actually, let me rewrite that so you can actually read it. So I just plugged this function into itself. Weird. Alright, so let me go through here. I have two things multiplied together in a parentheses. If it's multiplied in a parentheses, I can distribute the exponent. So right now I have 3 and then a 3 to the -1 power, and for my x, -1 times -1 is a +1. Well, that's convenient because right here, 3 to the first times 3 to the -1 is like 3 to the 0, and 3 to the 0 is just 1, so that doesn't change anything. So my answer is just x this time. I don't have any square roots to worry about, I don't have any fractions to worry about, so my possible values that I could plug into x is anything, so my domain is all reals. Alright, if you're feeling up for a challenge, pause the video and try part B on your own before looking. If you're feeling still confused, just watch. I'm going to fully explain these because I'm guessing a lot of you might still feel like you don't really know what's going on here. We're going to go through the same process just with some different functions this time. So once again, always start with what's in the middle here. So this time what's in the middle there is g of x. So I'm going to write down g of x. And that's what I want to plug in to f. So f looks like this. And then in my mind I'm thinking, okay, erase, erase, erase the x, and then replace it with x squared minus 1. So let me just again rewrite that so it's easier to see. This is what I have. So again, I took the x right here and I just erased it and put in g. And now I need to simplify. So even though it has a big parentheses, it still has a negative exponent, so that moves that whole part to the bottom. And when I have an exponent of 1 now, because I moved to the bottom, that doesn't matter, so here I go. 2 over x squared minus 1. To find the domain this time, remember, we don't know, or maybe you do know just looking at it, what x cannot be, because I don't want 0 on bottom. But the rule of thumb is, if you're ever not sure, take the bottom, set it equal to 0, and then solve it. And that's how we can figure out what x cannot be. Remember, if I take a square root, x could be positive or -1, and that makes sense. 1 squared minus 1 would be 0. Negative 1 squared minus 1 would be 0. So this time my domain is all reals except 1 and negative 1. Alright, let's keep going. Find g of f of x. So again, always start with the 1 on the inside. F of x is 2x to the negative 1. I am going to plug that into g. So what I do is write down my g function. Right now, remember the normal g function looks like this. We're going to erase what x was and plug in the new thing in the parentheses, and that happens to be f. And then I need to simplify. And again here, I've got two things multiplied together in a parentheses. So if it's multiplied together in a parentheses, you can distribute the exponent. So it's 2 squared, which is 4, times x. And then negative 1 times 2 is a negative 2 for that exponent. So here's what I end up this time with. 4 over x squared minus 1. Alright, for my domain this time, again I'm thinking about what I can't have, and I can't have x squared equals 0, solve it. Okay, this time I just can't have 0, so the domain is all reals except 0. Last but not least, I'm going to do f of x with this function. So again, plug in what the middle thing is, think about that. Then I'm going to write down the function I'm using, which is f. I'm going to replace x with a parentheses, and then I plug this into the parentheses. And again, same situation I just had where I have something multiplied together to an exponent. So go ahead and distribute that. 2 to the negative 1, and then for this, negative 1 times negative 1 is 1 for that power of x. Alright, 2 is really like 2 to the first. So add those exponents. 2 to the 0 is 1. Final answer is x. We don't have any fractions or funky radicals, so x could be any value. So my domain this time is all reals. Great job, everybody. That is the end of 7.3.